In this video, I will show you how to make a vertex edge graph and how to read and understand one. So a vertex edge graph is a collection of points and line segments connecting some, possibly empty, subsets of those points. For example, this is a vertex edge graph where points like point F, A, B, C, D, those are the vertices. And then the segments that we have here are the edges. Vertex edge graphs can also be digraphs if you have arrows indicating a directionality between vertices. Vertex edge graphs are used in many fields in the real world. For example, in transportation, imagine a diagram showing flight paths between cities in major hubs, like for example the red is a major northwest hub, while the blue squares represent major delta hubs, and each of these lines represents a flight, a scheduled flight between cities. So let's do an example. All right, obviously this is way too complicated for us to draw by hand today, but this is going to be a little bit easier. Let's create a vertex edge graph showing the state boundaries in the southern states along the Atlantic coast. So we will let each state be represented by a vertex. Okay, so let's see. We will have Virginia and North Carolina and South Carolina and Georgia and Florida. Okay, so in this vertex edge graph, if two states share a boundary, then we will represent that connection by an edge. So, does Virginia, let's start with Virginia. Virginia shares a border with North Carolina and no other state. So we will draw an edge from between Virginia and North Carolina because they share a border. So we're really done with Virginia right now. Let's look at North Carolina. North Carolina, of course, shares a border with Virginia, but it also shares a border with South Carolina and Georgia. So we will make an edge between North Carolina and South Carolina, and between North Carolina and Georgia, all right, representing that it shares a border with those two states. So let's move on to South Carolina. South Carolina, of course, shares a border with North Carolina, which we've already covered, but it also shares a border with with Georgia. So we will add this edge showing the connection between South Carolina and Georgia, the shared border. All right, so that's it for South Carolina, only borders the two states. Let's move on to Georgia. So now, we've already covered the fact that Georgia shares a border with North Carolina and South Carolina. So that's why we have these two edges right here from Georgia to North Carolina and between Georgia and South Carolina. But Georgia also shares a border with Florida. So we will make another edge representing the shared border between Florida and Georgia. So as we move on to Florida, we see that Florida only has the one shared border with Georgia, and we've already covered that, so that is really the end of our vertex edge graph. Now, an airline serves 4 cities: Bedford, Columbia, Dunwich, and Exton. There are flights between Bedford and Columbia, Bedford and Dunwich, and Columbia and Exton. Draw a vertex edge graph to represent this situation. All right, I would invite you to pause the video and try to do this one by yourself. So we have 4 cities that start with B, C, D, and E. So that's what I'm going to do. So I've got B, C, D, and E. Okay, there are flights between Bedford and Columbia. So I will connect those two by an edge. Bedford and Dunwich, so that this edge will represent those flights. Columbia and Exton. All right, and that's it. So here is our vertex edge graph. Okay, now looking back at example 2, an airline serving these cities, etc. Now, we can draw an agency matrix to represent this situation. Okay, so the rows and columns of the matrix will be labeled like this. Alright, so I have B, C, D, and E across labeling the columns, and I have B, C, D, and E also labeling the rows. Okay, so a 0 means that there are no flights between the city represented by that row and that particular column. So of course we will have zeros all down the diagonal because there are no flights from Columbia to Columbia or from Dunwich to Dunwich. You don't have a flight from a city to itself. That's what these zeros represent. Okay, on the other hand, there was a flight between Bedford and Columbia. So between Bedford and Columbia, that's why there's a 1 here. And that's duplicated here because between Columbia and Bedford, that's the same thing. Alright, so as I look back, so see how there are flights between Exton and Columbia? So if I look here and I look at Exton and Columbia, that's why there's a 1 there. And that'll be duplicated from Columbia to Exton. That's why there's a 1 there. Okay, now if we input matrix A into our calculator, and we will find A squared. Alright, what does this represent? So let's put this in our calculator. Okay, so I'm going to go to matrix A. Well, I'm going to go to the edit menu, and I'm going to edit matrix A. Now the dimensions here, let me go back. So this is a 4 by 4 matrix. So I'll change the dimensions to 4 by 4, and I will just type this in. Okay, so I've got 0, 1, 1, 0. I've got 1, 0, 0, 1. And now I've gone on and typed in the rest of it. So I'm going to quit my way out of here, and I need to find A squared now. So I'm going to go back to the matrix area and choose matrix A, and then I'll just hit squared, and this is what I get. Similarly, if I want A cubed, I will go to the matrix menu, type matrix A. Now for cubed, I need to use my caret and type a 3, and this is what I get. So now there's the question of what does it represent? Well, the 2, as far as A squared, and the 3, when we talk about A cubed, represents the number of edges that we will cross. So I'll say more in a moment, but this means we're going to use 2 edges, and this 3 means we're going to use 3 edges. So now if I look at this 2 that's right here between Bedford and Bedford, this means the number of ways that we can go from Bedford and back to Bedford using 2 edges. So let's look at that. So here's our vertex edge graph. If we want to go from Bedford and end up back at Bedford, we could either start here and we could go 1 and then 2 and we're back. That's one way. Let me see if I can change colors real quick. Another way is we could start at Bedford, and here we go. There's 1 edge and then 2 edges. So these 2 colors represent the 2 ways that we could start and end at Bedford using 2 edges. So just for the sake of our notes, understand that this number right here represents the number of edges that we use, and these numbers represent the number of ways that you can do something. Alright, so again, this 3 means 3 edges, and all of these numbers represent how many ways there are to use 3 edges. How many ways? So let's do one more example. Okay, so using a to the 3rd power. So that means we want to use 3 edges. Let's look at this 2 right here between Bedford and Dunwich. Alright, this means that there are 2 ways to travel between Bedford and Dunwich using 3 edges. 2 ways, 3 edges. Bedford and Dunwich. Let's check it out. Okay, so we want to use 3 edges this time to get from Bedford to Dunwich. So how could I do it? I could go from here to here, and then I'd have to go back again, so that's 1 and then 2 and then 3. So this green represents one of the ways. I went 1, 2, and then 3. So I used 3 edges to get from Bedford to Dunwich. That's one way. Now I'm going to use another color to show another way. I want to start at Bedford, so I'm going to go straight to Dunwich. That's 1 edge. Now I'm going to go back to Bedford. That's 2. Now I'm going to go back to Dunwich again. That's 3. So I started at Bedford and I ended at Dunwich, but I used 3 edges. Count them again. 1, 2, 3. So this purple represents the 2nd way to get from Bedford to Dunwich using 3 edges. So for example, this 2 right here means that there are 2 ways to get from Exton to Columbia using 3 edges. Alright, so again, this 2 represents how many ways, and the 3, because we did a to the 3rd power, tells us how many edges we use. Alright, example 3. Consider just the relationships between raccoons, fish, and frogs in the food web shown, and create a vertex edge graph to represent it. I feel like maybe I should change the wording of this because we already have the vertex edge graph, so they must be asking us to make a matrix. Okay, so we have 3 things. We have our frogs, which include tadpoles apparently. So we have our frogs, fish, and raccoons. So this is going to be a 3 by 3 matrix. And so I'll put frogs, I'll put FT for frogs / tadpoles, as opposed to I'll put a single F for fish. but we'll have R for raccoons, and we'll have F for just fish. So here again, the rows will be labeled frog tadpole, raccoons, and fish. Okay, notice this is a digraph. Notice the arrows. Okay, so we're talking about a food web. So what do you think these arrows represent? Alright, see the arrow going from raccoon to frog. So that means raccoons eat frogs. There is no arrow from frog to raccoon because frogs do not eat raccoons. So the direction really matters. So, okay, let's nail this down. Let's start with frogs and tadpoles. Are there any arrows going from frogs and tadpoles to anything else? No. Frogs and tadpoles don't eat raccoons or fish. So they don't even eat themselves. They are not cannibals in any way. So we'll have a 0 here, a 0 here, and a 0 here. Frogs do not eat other frogs. Frogs do not eat raccoons, and frogs do not eat fish. Okay? Now let's move down to raccoons. Do raccoons eat frogs or tadpoles? Okay, according to this chart, yes, raccoons eat frogs and tadpoles. So we're going to put a 1 right there. Okay, and this specifically means raccoons eat frogs and tadpoles. It goes in that order. Okay, raccoons eat frogs and tadpoles. Okay, now do raccoons eat fish? Yes, they do. So I'll put a 1 here to show that raccoons eat fish, and it has to go in that order. Raccoons eat fish. Raccoons do not eat other raccoons, so we'll just put a 0 right there to show that raccoons do not eat raccoons. Alright, now let's move down to fish. Alright, do fish eat frogs and tadpoles? Yes, fish eat, and probably they're talking about tadpoles here, but fish eat frogs or tadpoles. So I'm going to go ahead and put a 1 there, and this means fish eat frogs and tadpoles. Do fish eat raccoons? No, fish do not eat raccoons. That's why there's no arrow going that way. So I'll put a 0 here. Now, do fish eat other fish? Yes, some fish eat other kinds of fish. So that's why there's this curly arrow pointing from fish back to itself, because fish eat fish. And so we will have a 1 there. So that's how you could make a matrix, an agency matrix, representing this digraph. Okay, now let's look at a more complex web, a more complex food web. And let's make the agency matrix for it. Now this is a digraph, so direction does matter. I'm just going to do 1 row at a time. So I'm going to start with bears. Do bears eat bears? No, there's no curly arrow pointing back to bears, so I'm going to put a little 0 right there. Do bears eat crayfish, which is what the CR must stand for? Do bears eat crayfish? No, bears do not eat crayfish. There's no arrow there. Do bears eat fish? Yes, they do. So that there's an arrow from bear to fish. So yes, bears eat fish. I'll put a 1 right there. Do bears eat frogs? No. Here's our frogs and tadpoles. Bears do not eat those, so I'll put a 0 right there. Do bears eat insects? No. Insects are over there. There's no arrow. Bears do not eat insects. Do bears eat mice? Yes, bears eat mice. See the arrow? Bears eating the mice. That's a 1. Do bears eat raccoons? Apparently not. Somehow raccoons get let off the hook there. Bears do not eat raccoons, so I'll put a 0 right there. Now, I encourage you to pause the video and complete the rest of this agency matrix on your own. Alright, now I'm just going to pretend that you did that. So let's move on to crayfish. What do crayfish eat? Let's see. Crayfish eat insects, and that's it. Okay, there's only one arrow going away from crayfish, and that's to insects. So crayfish eat insects. So I'm going to put a 1 right there. Maybe I'll change colors. I'll make this easier. Alright, crayfish eat insects and nothing else. So I'm just going to put zeros everywhere else. Let's move on to fish. Alright, let me grab another color. Let's do green this time. Alright, fish. Okay, I'm looking at each of the arrows going away from fish, and I see 4 of them. Fish eat insects, fish eat crayfish, fish eat frogs or tadpoles, and fish eat other fish. So fish eat insects. Alright, fish eat crayfish, fish eat frogs or tadpoles, and fish eat other fish. But they don't eat bears or mice or raccoons. Okay, let me switch colors again for frogs. Okay, we'll see, where are my frogs at? Alright, frogs, I'm looking for the arrows going away from frogs. Frogs eat insects and frogs eat crayfish. Okay, frogs eat crayfish and frogs eat insects. So I'm going to put zeros everywhere else because frogs don't eat any of those things. Okay, let's go on to insects. Okay, I'm looking for arrows that go away from insects. There's only one arrow going away from insects, and that's the one that leads back to insects, because insects eat other insects. Okay, so I'm going to put a 1 right here representing that. Insects don't eat bears or crayfish or fish or frogs or mice or raccoons. So I'll put zeros in all of those other places. Alright, let me change colors. Okay, now let's talk mice. I'm looking for arrows that go away from mice. There's only one of them. Mice eat insects. Okay, so I'm going to put a 1 under insects. Okay, showing that mice eat insects. Alright, but they don't eat any of these other things. So I'm going to put zeros all across that. Okay, let me change colors one more time for raccoons. Okay, so I'm looking for arrows that go away from raccoons. I see 3 of them. Raccoons eat insects, frogs, and fish. Okay, raccoons eat insects, frogs, and fish. Okay, but they don't eat any of these other things. Alright, so there you go. Let's do one more example. Within a small group of associates, different people are willing to share secrets selectively. Alan will share with Elise. Brett will share with Chloe and Alan. Chloe will share with Elise and Dora. Dora will share with Fiona and Elise. Elise will share with Alan and Brett. Fiona will share with Alan and Brett. Show this information with a digraph and agency matrix named S. So let's see, what do we have here? A, B, C, D, E, F. Nice. I love it when they do that. Okay, so here we go. A, B, C, D, E, F. Okay, Now let me change colors for these edges. So those are my vertices. Alan will share with Elise. So Alan shares with Elise. Okay, now this is a digraph. We're going to have arrows happening. Brett will share with Chloe and Alan. So Brett will share with Chloe and Alan. Chloe will share with Elise and Dora. Alright, Chloe will share with Elise and Dora. Okay, Dora will share with Fiona and Elise. Alright, Dora will share with Fiona and Elise. Okay, I just curved it a little bit so you could see it. What else? Elise will share with Alan and Brett. Okay, man, this is getting complicated. So Elise will share with Alan. So I'll just put another arrow on the end of that. And Brett. Okay, Fiona will share with Alan and Brett. So Fiona will share with Alan and Brett. Okay, I wish I had made that a little bit bigger. Oh, alright, so now we need to make a matrix representing this. So this is going to be a 6 by 6 matrix. So as I make the agency matrix for this digraph and we name it S, probably the easiest thing to do is go back to the words. I could get the information from my graph, but it's a little bit crazy in there. And they really give us all the information very clearly here in words. Alan will share with Elise. So Alan sharing with Elise would be a 1 right here. Alan doesn't share with anybody else. So that means we have zeros everywhere else. Okay, now we move on to Brett. Brett will share with Chloe and Alan. So Brett shares with Chloe and Alan. Nobody else. Chloe will share with Elise and Dora. So Chloe will share with Elise and Dora. Nobody else. Dora will share with Fiona and Elise. Dora will share with Fiona and Elise. Nobody else. Elise will share with Alan and Brett. Elise will share with Alan and Brett. Nobody else. Fiona will share with Alan and Brett. Fiona will share with Alan and Brett. And nobody else. Okay, so there is our agency matrix S. What do the zeros on the diagonal indicate? You can't share a secret with yourself. So Brett can't share with Brett. So that's what that represents. Okay, so fine, you can't share secrets with yourself. Now we're supposed to determine what s squared and s to the third power would mean in this situation. And I've gone ahead and created the matrix s to the third power. So remember that these exponents mean the number of edges that would be used. So this 2 And this 3, we're talking about 2 edges and 3 edges being used. Alright, now the numbers in the actual matrix mean the number of ways for something to happen. So let's pick out one example and talk about it. Look at this 2 right here. Let's talk about what this 2 means in this situation. Alright, this number 2 means the number of ways. There are 2 ways that Dora can share a secret with Chloe. Alright, and that's the order of this, from Dora to Chloe. There are 2 ways to share for Dora to get a secret to Chloe while using 3 paths on this diagram. Okay, so let's write that down. Okay, and I went ahead and I squeezed that in here as best I could. The 2 circled on the s to the 3rd power matrix means there are 2 ways for Dora to share with Chloe using 3 edges. Alright, 2 ways, 3 edges. Alright, the 2 means the number of ways, the 3 means number of edges. Alright, let's take a closer look at that. So we're talking about Dora sharing with Chloe using 3 edges. Okay, so if Dora is going to share with Chloe using 3 edges, let's see if we can find one of those paths. So Dora could share with Fiona, and then Fiona could share with, I forget who started with B, Brett, and then Brett could share with Chloe. So this is one way that Dora could share with Chloe using 1, 2, 3 edges. Alright, now according to the s to the 3rd power matrix, there is another way that we could do that. So let me switch colors and see if we can find another way. Okay, let's see. So what if Dora shared with Elise, and then Elise shared with Brett, and then Brett shared with Chloe? That is the second way that Dora could get a secret to Chloe using 3 edges. Okay, so there you have it. The number 2 on the s to the 3rd power graph meant that there are 2 ways, the yellow and the blue, of getting a secret from Dora to Chloe using 3 edges. That's what the 3 of the s to the 3rd power means. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.